is Eric Oseland. I'm a graduate student in the Weed Science program at the University of Missouri. Our paper, titled Identification of Environmental Factors That Influence the Likelihood of Off-Target Movement of Dicamba, was recently accepted and published in the scientific journal Pest Management Science. I wanted to take a few minutes to summarize the results of this research and how they relate to dicamba applications occurring in Missouri and across the Midwest. For a brief overview of the methodology included in this paper, we collected information pertaining to dicamba applications applied in several states from a network of agricultural retailers and weed scientists in 2017. Each of these applications was labeled as either unsuccessful, meaning that some sort of unexplained off-target movement event occurred following this dicamba application, or successful, meaning that no indication of off-target movement occurred following that dicamba application. Now, it's important to note the word unexplained, as we only evaluated unexplained movement and not physical drift or tank contamination. So for each of these applications, we recorded a series of environmental and meteorological data which was statistically analyzed in a way that allowed for certain factors to be selected as indicators that influence off-target dicamba movement. The results of our study found that there are several factors that influence off-target dicamba movement. Some of them have been reported in previous weed science literature, and others had not yet been evaluated. Moving into the results, air temperature was significant in the model. This aligns with previous research from many weed scientists who have found that increasing air temperature increases dicamba volatility, which likely results in off-target movement. The next finding was wind speed. Now, since we didn't analyze off-target movement events that originated from physical drift, it was not higher wind speeds that were found in our study to increase dicamba off-target movement. Actually, what we found was low wind speed was what increased the likelihood of dicamba moving off target. This result is attributed to the fact that when dicamba applications occur, wind is necessary to disperse the particles that are suspended in the air. Also, we found that wind speed on the day following application also influences the likelihood of successful dicamba applications. Therefore, it's important to pay attention not only to wind speeds on the day of application, but also on the day following application. The next factor that was found to influence the success of dicamba applications was soil pH. And we decided to take this finding a little further and test it in the field for two reasons. One, this finding had not been reported in any weed science literature, and two, this allowed us to test the accuracy of our model in a field situation. In 2018 and 2019, we collected large quantities of soil from the Bradford Research Center. We added amendments to this soil to acidify and alkalize the soil pH to 5 distinct soil pH levels. We then set up plastic low tunnels that measured 20 foot long over the top of 2 rows of dicamba-sensitive soybeans. We took the pH adjusted soil and filled plastic greenhouse flats and then applied 1 of 4 dicamba formulations to the soil inside of each flat. The dicamba formulations included in the study were Extendamax, Ingenia, an experimental formulation of dicamba consisting of a choline salt, and Clarity, which was included as a comparison treatment of a known volatile dicamba formulation. These flats were then placed beneath the plastic low tunnels for 72 hours. 2 weeks later, visual injury ratings were taken to evaluate the soybean exposure to dicamba vapors that volatilized from the soil flats. The results of this study found that when soil pH was lower, more dicamba volatilized from those treatments. As soil pH reached levels of 7 and greater, we no longer saw increases in dicamba volatility from those treatments. When we look at the results from both years a little closer, broken down by soil pH and dicamba formulation, we observe similarities between Clarity, Extendamax, and Ingenia at the 4.3 pH as well as the 5.5 pH. However, when soil pH reached 6.8 and above, we no longer see similarities between Clarity and the approved dicamba formulations. Dicamba choline was also influenced by soil pH, but overall showed promise as a lower volatile dicamba formulation than what is currently available. Looking through some images of what this injury looked like, you can see the substantial level of cupping we observed in the lowest soil pH with Clarity. However, you don't see much of a reduction in cupping in either the Extendamax or Ingenia treatments, but there is a reduction in injury in the dicamba choline treatment. Alternatively, when we look at the same dicamba formulations applied to a soil with pH of 7.7, we once again see a fairly substantial level of injury from clarity, but we no longer see similarities in the injury levels caused by Ingenia or XtendiMax, and injury from dicamba choline at this soil pH is almost zero. The final factor that was identified to increase the likelihood of off-target dicamba movement included the proximity of the nearest large water source. It is likely that dicamba suspended in the atmosphere gravitates toward the lowest topographical point due to cool air drainage. This result coincides with anecdotal reports from Missouri and other states that have seen dicamba injury be especially pronounced along major water sources. The results of this study show that there are many factors that can influence the success of dicamba applications. Some of these factors are difficult to measure or predict, which causes dicamba applications to be especially challenging. However, closely following the label, ensuring wind speeds are high enough to disperse the droplets, but not high enough to cause physical drift is important. Also, it is important to pay attention to the weather on the days following dicamba applications, as our other research has shown dicamba can volatilize from soybeans for at least 72 hours after application. Lastly, it is important to take care not to expose dicamba to low pH conditions, whether that be in the spray tank or on the surface to which dicamba is applied. Keeping all of these factors in mind when making dicamba applications can increase the likelihood that dicamba will remain on target.